Okay, in this video, we're going to remind you of order of operations. We're going to remind you of different operations that we perform on expressions, algebraic expressions. Now, I do want to point out, and a lot of people have issues with this, these that we're working on today are expressions. The reason we call them expressions and not equations, a lot of people get those mixed up, is there's not an equal sign anywhere in this. Now, we're wanting to try to figure out what it is equal to, but equations have equal signs. This is an expression, an algebraic expression, not an equation. Now, first off, order of operations. A lot of us are used to PEMDAS, and they've replaced here the famous PEMDAS with GIMDAS. And the reason they've done that is because G stands for grouping symbols. A lot of people are confused, but parentheses, which are located right here, are not the only grouping symbols. You have parentheses, you have brackets, you have braces, and anytime you have a fraction bar, that is also considered, and actually absolute value bars is also a type of grouping symbol. So let's go through and remind you of order of operations. Number one, simplify the expressions. First off, let's do all grouping symbols first, and we have some grouping symbols here. So inside of grouping symbols we have, and if you can do this whole thing in your head inside grouping symbol, that's great. Let me zoom in a little bit. So you have 11 minus, or 29 minus, you have 11 minus 2 to the third. We always, inside the grouping symbols as well, we have to follow these orders. So inside of grouping symbols, if you have other grouping symbols, do those first, and then do exponents, then multiply, divide, then add, subtract last. So we do have some exponents here. 2 to the third means 2 times 2 times 2, which is 8. Everything else stays the same. We still have not gotten rid of those grouping symbols, so let's go ahead and finish it up by doing 11 minus 8. Now we have done everything inside of grouping symbols so we can get rid of them. Now the rest of them, we've gotten rid of the G, so now let's move on to exponents. We do have some exponents here. So 29 minus 3 plus 6 to the second power, that's 6 times 6, which is 36. We finished with all the exponents, so let's move on to multiplication and division. Now multiplication and division, remember that is done from left to right. So as you reach it, you'll always do from left to right. So 29 minus 3 plus 36 divided by 4 is 9. Addition and subtraction is your last step. It is also done from left to right. So we're going to do 29 minus 3 first. That'd be 26. Bring down the plus 9, and 26 plus 9 gives you 35. Okay, number 2. Grouping symbols, exponents, multiply and divide, add and subtract. 4 steps. Grouping symbols, we do have some absolute value bars here. If you don't remember, everything inside of absolute value bars, if it's a negative, make it a positive. If it's a positive, leave it positive. If there is any operations in there, though, if there's addition and subtraction, always do that before you make it positive or negative. So since you have absolute value bars around a -8, simply remove them and make it an 8. This minus sign is here, so don't be confused by that. This is a positive 8 with a negative or a minus symbol in front of it. So bring down times 6 divided by 16. Exponents are next. So here's your exponents. 4 times 4 times 4 is 64 minus 8 times 6 divided by 16. We will now multiply and divide in order. 64. Now, here's something I want you to get into a habit of. This 8, since it's a minus in front of it, treat it like a -8. So you have a -8 times 6. That's a negative. Negative times a positive. A negative times a positive is a -48. Bring down divided by 16. We are still on multiplication and division. So now we've got to do the 48 divided by 16. Again, treat that 48 as a negative. Negative 48 divided by 16 is a -3. And the last step, 64 minus 3 is 61. Number 3, grouping symbols, always first. So actually, since you have fraction bars, this whole top is grouped together. The whole bottom is grouped together. A fraction bar works as grouping symbols. So what I'd probably do is let's work the top first. Let's work this as 2 completely separate problems. So 7 minus, in parentheses, 10 minus 12. Now, as I'm writing this, well, let's go ahead and write it. 10 minus 12 in absolute value bars plus 5 to the second power. There's the top. So inside of these grouping symbols, we have more grouping symbols. We have parentheses here, and we also have these absolute value bars here. You always start on the innermost ones, which is the absolute value bars, because those are inside of the parentheses. So let's do those first. Absolute value bars means your answer you're going to make positive, but actually do the operation first. You have to do 10 minus 12 before you make it positive. So now we have 7 minus parentheses. The absolute value bar, absolute value of 10 minus 12 is the absolute value of negative 2 plus 5 to the second power. And if you would like to, instead of having to rewrite that whole thing for one step, the absolute value of negative 2 is positive 2. Inside of here, we have addition and we have some exponents. Exponents come before addition, so you now have 2 plus 5 times 5 is 25. That would be 7 minus, inside parentheses, 2 and 25 is 27. 7 minus 27 is a negative 20. That's the top. Now let's do the bottom. Let me change colors here. On bottom, you have 9 minus 2 to the second power. Exponents come before subtraction, so that'd be 9 minus 2 to the second power is 4, which is 5. So the bottom is equal to 5. So the top was negative 20. The bottom was equal to 5. Now we can actually combine the two. Negative 20 divided by 5. Negative divided by positive is a negative. 20 divided by 5 is 4. Number 4. You have several grouping symbols here. We're going to, since it's a fraction bar, again, that's one giant grouping symbol. We're going to group everything on top. We're going to group everything on bottom and do them separately. So on top, we start with the innermost. We're going to start with these grouping symbols that are inside the other grouping symbols. You have 2 minus 3 to the second. And just to save ourselves a step, as I'm writing those down, I'm going to do 3 to the second power, which is 9. So on top, I have 2 minus 9, all raised to the second power, plus the square root of 81. Now, I didn't tell you a while ago, but actually square roots are also a type of grouping symbols. The reason why is because everything that's under it is grouped along with it. So if you had like the square root of 3 minus 2, that is grouped together under that square root. Now, something else, a square root, now you don't have a square root step. So when do you actually take the square root? Right here. A square root is, we'll learn later on, is also another way of writing an exponent. A square root is the same thing as a 1/2 power. So we're going to treat that as an exponent. We're going to do that in our second step. So parentheses, let's go ahead and finish those up. Inside parentheses, I have a 2 minus 9, which is negative 7, squared plus the square root of 81. We're finished with grouping symbols. Now let's do some exponents. Negative 7 to the second power. That's negative 7 times negative 7 is a positive 49. Plus, I told you that a square root is a type of exponent. So the square root of 81 is, we can do it in the same step as 9. So the top is equal to 58. Now let's do the bottom. On bottom, we have 10 minus 6 divided by 3. So you only have two operations, subtraction and division, and you just pretty much have to say which one of those comes first, and that would be division. The 6, since it has the minus sign there, though, treat it like a negative. Negative 6 divided by 3 would be a negative 2, and 10 minus 2 is 8. So therefore, my top was 58, and my bottom was 8. Now let me show you in math how I want you to treat fractions or division. It's the same thing. This is 58 divided by 8. It is also 58 eighths. Make sure that you understand that division and fractions mean the exact same thing. So there's a couple of different ways we can handle this. We can actually divide it. However, when we divide it, let's see, 8 will go into 58 7 times with 2 left over. You end up getting 7.25, I believe. So that's one way we could write it as a decimal. Or if you would like to leave your answer as a fraction, you can simply reduce the fraction. I'm fine with either way, all depending on how they request their answer being written to reduce this fraction. 58 divided by 8, top and bottom are both divisible by 2. So to reduce fractions, we divide the top and the bottom by the same value. If you divide the top and bottom both by 2, you get 29/4. And you could actually divide it there and you're going to get that same decimal answer, but that is, either one of those answers are fine, all depending on how they want you to leave your answer. Number 5, got a lot of grouping symbols on top. So as I write this down, 15 minus, these are the innermost grouping symbols. So we're going to do this negative 6 plus 2 first as I write it down. So it'll be 15 minus negative 6 plus 2 would be a negative 4 plus the square root of 9, close parentheses, and that whole thing is being squared. So we've got our next set of grouping symbols. I can go ahead and take the absolute value of negative 4 right here. And again, if you don't want to write that whole thing down, you can mark it out and put a 4 in its place. Absolute value, just make it positive. So inside of these grouping symbols now, I've got to do 4 plus the square root of 9. And I don't mind for you starting to skip steps here because that's going to be a lot of steps if you're showing all these. This would be 4 plus the square root of 9. I can go ahead and do, that's 3. This is 4 plus 3, which would be 7. That'd be all of that symbol squared. So really, these parentheses here are not really necessary. You have 15 minus 7, which is 8 to the second power, which is 64. So the whole top is 64. Now let's do the bottom. The bottom is 3 minus, and I like to, as I'm writing it down, why not go ahead and do 3 to the third power? That's 3 times 3 times 3, which would be 3 minus 27, which is a negative 24. So the top was 64. The bottom was a negative 24. So different ways we can treat this problem. Again, it's a fraction or it's division. Since 24 won't go into 64, you could divide it and write the decimal form. That's fine. Or if you'd like to treat it like a fraction, here's something else I like to do. Since it's positive divided by negative, let's write that negative out front. 64 divided by 24, let's reduce it. I know that the top and bottom are both divisible by 4. And I think we actually divide it by 8. We could go a step higher. Let's divide top and bottom by 8. That'd be an 8 on top and a 3 on bottom. That'd be negative 8/3, which if you would have divided would have gave you, I believe, negative 2.6. Either answer would be fine. Number 6. Now we've got a fraction bar, so we've got to do that whole top and bottom separately. The bottom's kind of easy. The square root of 49 is 7. 7 plus 5 would be 12. The bottom's going to be 12. On top, if you would like to do it like this as well, you could start marking stuff out as you do it. Like 9 minus 15, that'd be negative 6 in parentheses. 7 minus 2 to the second. 2 to the second's 4. So 7 minus 4, this would be 3 over here in these parentheses. So on top, you now have negative 6 to the second power times 3. On the bottom, you have 12. Okay, I've already done the bottom, so I'm going to go ahead and write it down. On top, you have negative 6 to the second power. That's 36. Then you have times 3. So the top is 108. 36 times 3 is 108. On the bottom, you have the 12. Now, don't forget, we've also got this stuff over here. So we need to write down minus the absolute value of negative 5. Now, that's entirely inside an absolute value bar. If you'd like to go ahead and make that positive 5, you can. So we did everything on the top together. We did everything on the bottom together because they were grouped together. We did this by itself. So now we have this division, this big division bar. 108 divided by 12 is 9. Then you got to subtract this 5 that was out here. Final answer, 9 minus 5 is 4. Now in the next section, we're doing the exact same thing except for we're evaluating expressions. Now, evaluating expression means we're going to take some variables, we're going to plug them in and do the exact same thing. Here we got a times b squared divided by c plus 12. And they tell us what a is, what is b, and what is c. So we're going to take and plug those values in, and we're doing the exact same thing. Remember that anytime you have a fraction bar, it's implied parentheses. So on top, you have multiplication, and you have an exponent. So on top, I would do my exponent first. So when you plug in 3, or 3 for a, you have now 3 times. Why not just go ahead and square it as you're plugging it in? You've got to square negative 4. Now, as you plug these values in, here's something, a good habit to keep. As you plug them in, put them in parentheses if they're a negative especially. So you have 3 times negative 4 is being squared. So if you would like to go ahead and square that, negative 4 times negative 4 is a positive 16. On bottom, you have C as 8, so you now have 8 plus 12 instead of C plus 12. Do the top separately from the bottom. The top is 48. The bottom is 20. And we're going to do the same thing. We're going to treat that as a fraction. We can divide it, 48 divided by 20, or you can simply reduce it like a fraction. I think, let's see, I know that 4 will divide into both of these. Would give you a 12 on top and a 5 on bottom. You could have also divided here, and you would have got 2.4. Either answer is fine. But just to let you know that sometimes it's better to reduce it, and then you can actually see, once you reduce it, what that would divide into. Absolute value bars, 10m minus 8n squared. So the first thing you're going to do inside of those absolute value bars is square the n as you plug it in. So I'm going to go ahead and with this one, we'll go ahead and as we plug them in, we'll just put them in some parentheses. So we have 10 times m, which is 10 times 2, minus 8 times n to the second, it would be negative 3 to the second. Very important that we put these parentheses, because look what happens if we didn't there. See what happens, what it looks like? So you can see there it looks like a minus 3. So make sure that you put those parentheses so that you can see this is multiplication and we're raising it to the second power. So inside the absolute value bars, we're going to do our exponents first. So we now have 10. And now these parentheses here, if you'd rather put it as times 2 like that, because it's a positive number, so they're not really necessary. Minus 8 times negative 3 to the second power. Negative times negative is a positive. 3 times 3 is 9. So now you have this. You have 2 sets of multiplication. We can actually do them both in the same step. 10 times 2 is 20, minus 8 times 9 is 72, or you can think of it as a negative 8 times 9 is a negative 72. 20 minus 72 is negative 52. And when you take the absolute value of it in the last step, and again, do not take absolute values until you've done all operations. The absolute value of a negative 52 is a positive 52, and that is your final answer. Okay, number 9. Very important here, and this is one of the most missed things in all of algebra. When you plug in this x, again, think of that 5. As you plug it in, that 5 is in parentheses. So therefore, what you are squaring right here is not negative 5. You're going to square the 5, and then you're going to leave the negative sign in front of it. A big, like I said, a big deal is the difference between these two things, or even without the parentheses here. Negative 5 squared versus negative 5 squared. Anytime you're squaring something in parentheses, you're going to square this whole thing. It's a negative 5 times negative 5, which is a positive 25. However, if you have a negative and then you have the 5 being squared, that's the same thing as the negative of 5 squared. You're going to square this and you're going to leave the negative. So that would be a negative 25. So if it's in parentheses, negative 5 squared, you end up with a positive. If it's just the 5 in parentheses, or if you don't have parentheses, if it's negative and then the 5 squared, both of those would end up in a negative 25. So be super careful about the difference between those. Plus 7 parentheses, and y is negative 9. And you really don't need parentheses around that because it's not multiplied or anything like that. We can do negative 9 plus 2 in our head there. So let's start with anything inside of grouping symbols. And the grouping symbols that we have has negative 9 plus 2, which is a negative 7 inside of it. Next up, we're going to do any exponents. Leave this minus out front and do 5 to the second power, which is 25. Next up, we multiply and divide, so we now have negative 25. Now, here's something that I'm kind of super particular about. I like for you to treat this as a positive 7 and you're multiplying by a negative 7. And a positive times a negative would be a negative. So this plus sign is actually going to be a negative now, or a minus sign. A 7 times a negative 7 is a negative 49. And it just, to me, looks better. Because I'm not a big fan of having a plus sign and then a minus sign next to it. So this, like I said, just looks better. Then all of my subtraction, we're going to just subtract from left to right. You have a negative 25 and a negative 49 and a negative 1, which gives you negative 75. Number 10, 3 times r, which is 5, minus 4 times s, which is 2/3. Multiplication comes first because we don't have any exponents or anything inside a grouping symbol, so 3 times 5 is 15. And in the same step, we can go ahead and multiply 4 times 2/3. That will not cross cancel, so 4 times 2 is 8. 1 times 3 is 3, so we have 8/3. So 15 minus 8/3. Now we have a couple of options here. You can take 8/3 and you can change it to a decimal by dividing. That would be 2 and 2.6 repeating and do 15 minus that. I like to find common denominators and treat it like fractions. So we have 15/1 minus 8/3. Your common denominator is going to be 3. So let's take top and bottom over here, multiply by 3. It gives me 45/3 minus 8/3, which is going to be 37/3. And again, you can leave it like that, or you could write it in decimal form. Number 11. Notice here that the x is being squared. So as you plug in that -6, put it in parentheses, -6 to the second minus the same thing with y, 8 to the second. So you actually see both examples in this one problem of what I showed you previous. We'll talk about it in just a second. Minus your x value is -6 and your y value is 8. And you can always put them in parentheses as you're writing them down if you want to. But let's address this. You have -6 to the second power, and you also have -8 to the second power. When you square a -6 times a -6, there you're going to get a positive 36. However, in this one, you're going to leave the minus sign, and you're squaring just what's in parentheses, the 8. So the minus sign stays, it's still negative, and you do 8 times 8, which is 64. Minus -6 times 8. Let's finish up the stuff inside our grouping symbols. 36 minus 64, I'm going to just write that above it. That's going to be a -28 when you subtract that. So inside of absolute value bars, you have -28. Now we can go ahead and take the absolute value -28, and it gives you positive 28. Now over here, treat this, think of it as being actually 3 different things being multiplied together right here. That minus in front is like a -1. So it's kind of like having a -1 times a -6 times an 8. So you can multiply them from left to right if you'd like. -1 times a -6 is a positive 6. And then multiplying that by 8 gives you a positive 48. Now, a lot of people do it like this. They'll leave the negative sign. Let me erase some of this. A lot of people will leave this negative sign here, and they'll multiply this times this. And they'll have negative 48. If you'll do it the way I showed you, you don't have to do that extra step of changing the two minuses to a plus, but you would have 28 plus 48, which is 76. Number 12, you have 2/5, parentheses, a is 3 plus 2 times b is 2 times -4, all to the second power. So that gives you 2/5. We got to do the stuff in parentheses first. Make sure you multiply before you add. Treat this as 3 and a positive 2. The plus 2 is the same thing as positive 2. You have a positive 2 times a -4. Now this is where it goes back to what I said a while ago. A positive times a negative is a negative, so why not just change that to a minus sign? And 2 times 4 is 8. Just makes it look so much better instead of leaving that positive or plus sign there. So now you have 2/5, parentheses, 3 minus 8 is a -5 to the second. That'd be 2/5 times -5 to the second. Since this whole thing is in parentheses squared, that'd be a positive 25 because it's a negative times a negative. 2/5 times that, fraction bar, put it over 1 so we can multiply it. Let's do some cross canceling, mark out 5 and 25. Both of those numbers are divisible by 5. 5 into 5 is 1. 5 into 25 is 5. Multiply tops and bottoms gives you 10 over 1, which is 10. Number 13. W to the third, and that would be 2 to the third. Really not necessary to put parentheses there. Minus 4 times 18 over the square root of W times V. And now since this is inside of some grouping symbols, if you'd like to go ahead and do W times V, you can to clean it up a little bit ahead of time. Now since you are dealing with fraction bars, the whole top and the whole bottom have implied parentheses. You can't do anything unless you're using like a distributive property or something like that until you take care of those parentheses. So the bottom, pretty easy, is 6. The top, I'm going to do some exponents first. That's 2 times 2 times 2, which is 8, minus 4 times 18. Now you could go ahead and write that step down, or you can go ahead and do the 8 and the 4 times 18 will not impact each other anyway. So since you went ahead and cubed this, if you would like to go ahead and multiply this together, because this is going to be the next step anyway, you could have a negative 4 times 18 will be a negative 72. You can do it in one step or two steps. Now let me show you this. If you would like to use that distributive property that we talked about in an earlier lesson, you could at this step. It's going to come out pretty nasty, but both of these things are being divided by 6, so you could distribute. You could use that property here. We're not going to. We're going to go ahead and subtract the top. 8 minus 72 is a negative 64 over 6. Now, the way I want you to treat this, if this is divisible, definitely divide it. 64 divided by 6 is going to give you a decimal answer, though. I would rather, just to keep it clean, if it's going to be a decimal answer, why not just leave it as a fraction? Take the top, this is a negative divided by positive, which is a negative. Divide the top and bottom by the same value. Let's divide them both by 2, and you get negative 32 over 3, and you can just leave your answer like that. 2m squared would be 2 times 1/4 squared plus 9 times 1/4. Exponents are going to come first, so that's going to be 1/4 times 1/4. Now, to square a fraction, it is legal to square the top and square the bottom. That would be a 1 over a 16 plus 9 times 1/4. 2 times 1/16. I'm going to come over to the side and do 2 times 1 over 16. Cross cancel. That's a 1 and an 8, so that's 1/8. Plus 9 over 1 times 1 over 4. You can't even cross cancel that anyway, so that'd be 9/4. Before you can add these together, you need common denominators, which for 8 and 4, your common denominator is going to be 8. So this can stay 1 over 8. Multiply top and bottom by 2. That'd be 18 over 8. 1 plus 18 would be 19 over 8. That will not reduce, and if you try to divide it, it'll be a decimal anyway, so let's just leave it as 19/8. Okay, on the next one, now we're simplifying expressions. Okay, we're not plugging anything in, we're simplifying expression, which means we're simply combining like terms. We're using distributive property and all those things. Just some reminders from algebra. When you're simplifying expressions, when you're combining like terms, you can't combine two terms unless they are identical. What do we mean by identical? They have the same variables, exactly the same variables. So what we're going to be doing here is we're going to put our x's together by combining them. 16x's minus 7x's gives you a total of 9x's. A negative 11 and a positive 10 don't have x's, so those are also like terms. They're called constants. When you add the constant negative 11 and the constant positive 10, it gives you a negative 1 or a minus 1, and you're done. That's all your like terms. You combined all your like terms. Number 16, step number 1 here, we have some parentheses. So we're going to remove our parentheses, leave the 13, and we're distributing a positive 2. We're going to do positive 2 times both terms. Positive 2 times 3n is a positive 6n. That plus sign is necessary. A positive 2 times a negative 7 is a negative 14. Again, you have to put that minus sign. Bring down your plus 19n. Now simply look for like terms. I like to do my variables first. 6n's and 19n's gives you a positive 25n's. A positive 13 and a negative 14. If there's no symbol in front of it, it's understood to be positive. Positive 13 and negative 14 is a negative 1. Done. Number 17. Distributive property, 6 times c. And positive 6 times a negative 2 would be a negative 12. Now, there's no number in front of the second set of parentheses. If there's not, it's understood to be a negative 1. So we're going to distribute a negative 1 to both of those. Negative 1 times 8c would be a negative 8c, and a negative 1 times a positive 1 would be a minus 1. And again, we're just simply combining like terms. The c's, 6 minus 8 is a negative 2c. A negative 12 and a negative 1 combines to give you negative 13. Number 18. Look for your like terms. Let's do the y's. We'll do them in alphabetical order. Negative 15 plus 1 is a negative 14y's. Combine your negative 7z's and your positive 9z's, and that gives you a positive 2z's. So very important when you are combining, when you're adding, subtracting, do not change the variable. If you add z's with z's, you still have z's. If you add y's with y's, you still have y's, not y squareds or anything like that when you're adding, subtracting. Distribute the 3. 3 times 3 is 9. Still have an a. Positive 3 times a negative 5 is a negative 15, and you have 1b. Distribute the negative 1 to your second set. Negative 1 times a is a negative 1a. You don't have to put the 1 there. Negative 1 times a negative 7 is a positive 7. So there's one place some people might make a mistake. Negative times negative is a positive. 1 times 7b is 7b. Combine 9a's minus 1a gives you 8a's. Negative 15b's, positive 7b's is negative 8b's. And the last one. Distribute negative 8. Negative 8 times 2x is negative 16x's. A negative 8 times a positive would be a negative. 8 times y is 8y. Distribute negative 3. Negative times a negative is a positive 15x's. And a negative times a negative is a positive 6y's. Combining your negative 16 and positive 15x's gives you negative 1x. And you don't have to put the 1. You can just put the x. And a negative 8 and a positive 6 gives you a negative 2y.